I don't know how many of you have spoken at conferences. At least 23 of you have, because today or this thing. But like sometimes you follow up like a really good speaker, and you're like, fuck. And I'm following up all of them. So right now I'm in like super weird panic mode, and that's fine. It's been a really incredible conference, and as the last person up here, I get to do things like everybody give a round of applause for all the speakers. Applause. And a really, really big one for all of the organizers who can't possibly have done a better job. Thank you, seriously. The community here is amazing. So, as mentioned, I am Jeff Lembeck. This is my Twitter handle. Screens are there and there. I'm looking everywhere like, which one should I look at? Down there, probably. So there's my Twitter handle. You can like holler at me there and say really nice things about my talk while I'm talking, and then I'll get them afterward and feel super good. Or you can say like terrible things, and I'll block you just immediately, because who does that? Also, my slides are there. There's the URL for it. It has presenter notes inside of it, which I realized earlier that like I leave actual notes for myself, like don't do that, you fucking idiot. And that definitely made it in there this time. So, good times. So for some more unnecessary introduction, I am, once again, from Seattle. And I'm an extremely Seattle person, like every stereotype under the sun. I roast my own coffee. Yeah, God. But I don't drink Starbucks at all. So, more Seattle. This is a picture of Seattle that's incredibly accurate. I took it from my house. Don't Google what Seattle looks like. It's just like that, so just trust me. But most importantly, though, that picture is not a current picture of Seattle. It's from the before time. You see, today I'm here to tell you a story about a hero. So let's go. The world is veiled in darkness. Dependencies are inconsistent. Builds are slow. Version numbers matter not. The people wait. Their only hope, a prophecy. When dependency hell has plagued your JavaScript project, a tool will come. After a long journey, some programmers arrive, each holding a pretty loaded metaphor for a technical talk. I give to you Package Quest. Our story begins not so long ago when you, our hero developer, are given a mission. Hero developer, like any of you need a complex. Anyway, build a great website to honor your gods of user. Your gods are numerous and vengeful and will not tolerate an experience less than pristine. Your bosses, the masters of C-Team, are demanding that you appease the gods quickly so they can be granted riches in this life and the next. This task sounds grueling. Building each piece of a website from nothing involves strong magic, patience, and time. And in a world where each of these items is scarce, we need something to help us, something to guide us, something to give us the pieces that leave us less exposed to the cruel, monstrous insects that anger our user gods. There is a place that is spoken of that was used long ago, after the great programming war when the Dark Ages came into place. All of our help and hopes were destroyed, and speaking of this location, and the tool to get there was forbidden. But word of mouth was passed on from generation to generation, and you, our hero, will search out and find our land of our desires, the Registry. The only thing that we know is that to enter the Registry, there's talk of a tool, a magical weapon to destroy dependency hell that was forged by sorceresses of colorful hair. This tool survived multiple iterations and was faster and more powerful than anybody could have imagined. This tool is called NPM. NPM was cleanly broken apart by the sorceresses, in case the day ever came where NPM needed to be built again. Book 1, Chapter 1. According to old documentation found in the ruins of GitHub, our magical tool requires the help of 3 companions. Shishigami, the forest spirit. Pakoche, the master of packages. And Registry Client, a smuggler that can give you a special passcode to enter the registry. Each of these, when brought to the sorceresses of colorful hair, can be forged together by the light of JavaScript to create the NPM tool. And so, hero, to begin, we visit Shishigami, the creator of the dependency tree. The forest spirit's job is to piece together exactly what you need from your install. It scours through your list of package demands and also through what you already have installed and puts together an ideal tree, a perfect structure of your dependencies, so all your needs will be served. It achieves this by first reading your local package tree. It does this by combing through your node modules folder. Then, it reads your package lock JSON to make sure that the tree built from your node modules directory matches the tree from your package lock. After that, it is time to get the metadata for each missing package. At this point, Shishigami will call upon Pakoche. Pakoche's role within building a dependency tree is to reach out to the registry to get information about each package needed to be installed. According to the documented scriptures of Pakoche, this information will be delivered via Corgi doc. Okay, so it's literally called a Corgi doc, which naming of things internally at NPM is about this consistent. Because it's tiny. But so I go on the internet and I search Corgi doc because this is bound to turn up funny things. And this is the picture I get, and hell yes, every presentation I can ever fit it into. So, character, which is not a small and cute dog is represented here, but a very small piece of metadata that lets the tree worker know which versions of the package are available in the registry. Once this metadata is in place, the tree is normalized. Shishigami then puts together the ideal tree and calculates the difference between that and the tree that has been put together from the package lock and the metadata. This difference is where packages are moved, removed, or fetched and installed. Shishigami is located within the NPM repository. You go there and speak its name. It joins your party. Book 1, Chapter 2. Now that you have Shishigami, you will need Pakoche. Pakoche is the master of packages and comes equipped with her own caching system, Kakash. Kakash is Pakoche's nearly endless pack of fun. It is a key value storage system written in Node.js that is immensely fast. By the way, no shit, that is actually named Kakash. What it does best is get you the correct data quickly. It does this with great concurrency, incredible fault tolerance, support for SHA-1 and 512, and data consistency that notices if its data is corrupted. During installation with the NPM tool, Kakash stores the package data on disk. There. If the content is unavailable in the cache, Pakoche uses MakeFetchHappen to fetch the package. MakeFetchHappen is a wrapper around NodeFetch, which is a Node.js implementation of the browser's window fetch. MakeFetchHappen tacks on HTTP cache support, request pooling, and several more features to make it very easy to use and very fast. Its caching system relies upon Kakash. Because Pakoche knows that MakeFetchHappen uses Kakash as its caching system, when Pakoche is asked to fetch a package, it can use Kakash directly to get any data that it would use MakeFetchHappen to request before it uses MakeFetchHappen to get the package. So first it asks Kakash, do you know about the package I need? Many times, Kakash says yes, but when it says no, Pacoche can use MakeFetchHappen to go out and grab the package. Then, when MakeFetchHappen returns the package, it can be stored back inside of Kakash for Pacoche to get next time. Pacoche also provides an extractor in order to unwrap the packages that it is installing. Packages come from the registry in the form of tarball, and Pacoche understands how to make this into executable JavaScript for your consumption by unpacking the contents and placing that code accordingly. And as mentioned before, when dealing with Shishigami, Pacoche is capable of reaching out to the registry to grab the necessary metadata to understand just what packages you need. That metadata helps Shishigami by letting it know which versions the registry has of the packages you need, so it can build your dependency tree perfectly. Pacoche is largely the workhorse of the NPM tool and lives in a repository on GitHub where you can find her. You ask, she eagerly joins your party. If you actually want to find Pacoche, it's under cat, so it's zcat/Pacoche. I should have put the link there. Anyway. Book 1, Chapter 3. The last and final spirit you need to build the tool is the Registry Client. Much like many other API clients, the Registry Client is a wrapper around an external API. Registry Client allows you to talk to the registry for most anything revolving around your account and management of things you own. This includes changing ownership of packages, publishing and unpublishing packages, adding and removing members to and from your orgs and teams, and in this case, authentication. When you use the Registry Client for authentication, it asks you for your username, password, and email address. Then, it takes that to the registry and returns with an authentication token. When you authenticate, the registry remembers your token, and you store it in your npm-rc file. That token will be useful when you and Pacoche use the tool to go get your package. You find Registry Client lurking behind a corner on GitHub. You pass it a note saying, "Will you join my party?" It nods its head and follows behind you. Book 1, Chapter 4. Pacoche, Shishigami, and the Registry Client have guided you to NPM Inc., home of the sorceresses of brightly colored hair. They introduce themselves and walk you and your new party members to the installer. Within the realms of the installer, they forge together the spirits of your party members to be called upon any time you desire. Their magic is strong, and they have added to the tool the ability to increase its level to learn new skills and talents along the way, while simultaneously making the quest to obtain your packages smoother. You can do this by telling the tool to install itself. And as of today, As of today, you'll get version 6, but not like today right now, today West Coast time in the US. So tomorrow. Do it tomorrow. There's new functionality, an improved update command, a new npm view, a new init, which can take initializers like you can do npm init react app, and it will use create react app to create an application, and anything else that follows that very specific setup. npx is in there, and that was actually added in 5, but if you haven't updated recently, npx is the shit, and you should use it all the time, and if you don't use it, what are you doing with your life? Seriously, is anybody, show of hands, who's used npx in here? All the rest of you are wrong. CLI, 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 they chant. The tool is yours. Go, log in, then install. Book 2, Chapter 1. With the mission to forge the CLI complete, we turn to our map to see where the path forward leads. All signs point to the great registry, registry.npmjs.org. Let us make the journey. You start your quest at the land of Terminal Point. First, we log in. You pull out your CLI tool. You speak into it. npm login. the spirit of the registry client emerges. Username. J. Lembeck. Password. A very good password, probably. Side note, that password we just like won't accept anymore. And I think it's something like the top 70% of passwords won't be accepted. And soon you won't be able to use any either on like the Pwn to Own or the Pwn all the things, whatever site. Like that database of like 10 gigabytes worth of passwords, you can't use any of them anymore. Anyway. Email, jeff@npmjs.com. And with that, you're whisked away. We ride the road of the great network to the first destination on this request, the shopkeep. She goes by the name of CDN. CDN is a class who specializes in speed. She and her sisters, all with the same name and same personality, like just different locations, like a Nurse Joy or Officer Jenny kind of character. Anyway, if you get that reference, that's cool. Spread the globe and position themselves in ways so you'll get to them far more quickly than if you were to reach out to just one part of the world. She handles the cache for packages, and if you approach her with the name of the package you are looking for, she will do her best to get it for you. Unbeknownst to many, CDN also provides traffic routing. She handles all requests to the registry and will forward them along to where they need to go. How she does her work is largely based on two things: her cache and a light routing layer written in VCL. CDN looks at you. What brings you here? Authentication? Let me see. Right this way. CDN guides you to a path. Ahead lies Foyer. Go! You are whisked away to the next destination. Book 2, Chapter 2. Foyer operates as the entry point to the NPM registry. Information about packages, users, orgs, teams, and any modification to these things must first go through Foyer. Foyer also handles the path to authentication. You and Registry Client knock on the doors. From behind the walls you hear, "What is your purpose?" "I'd like to log in." "Hand me your credentials." One moment. The guard behind the door whisks away. Book 2, Chapter 3. NPM auth WS is who the guard takes you to, and is a gatekeeper for proving who you are and where you can go. She is quiet and only speaks with messengers from behind the doors of Foyer. NPM auth WS will be handling your authentication today. Authentication being when you can prove who you are. This is versus authorization, which is when you're checked to see if you have access to something. And this is a highly confusing thing to everybody because people say auth, and those two things mean different things. Use the whole word. HTTP spec. To check whether you're authenticated, NPM auth WS will reach out to the Synecdoche API. The Synecdoche API is the glue that binds together the two beholders of truth, User ACL2 and Payments API. Its API acts as a proxy for User ACL2. And when requests come through that gather or change information about payment, it also makes a call to the Payments API. They're easy to remember in these sweet illustrations because User ACL2 has like the fancy plume where she keeps track of everything, and Payments API has like a super fresh coat and lots of jewels. As the NPM auth WS reaches out to log in, the request is proxied through Synecdoche API to User ACL2. As mentioned, User ACL2 is the grand beholder of truth. If any changes are made to any accounts, it is written by User ACL2, and then that information is sent elsewhere via NSQ messages. Any of the calls to Foyer from the registry client that might involve changing teams, organizations, package permissions, or users, User ACL2. And most relevant for this story, logging in happens in User ACL2. NPM auth WS's trusty client friend, NPM OAuth User API. I just want to like put a picture of another dog in here. I can probably. it gets a token, it takes it off and checks it. Does this look, I'm like speeding through a thing here because it's totally unnecessary, but I like the dog. The token is passed back through the clients into npm auth ws, who takes your token and saves it. Into Redis, the great dictionary of keys and values. It will use this token in any instance where you need to access the registry again. Once it has done that, it passes the token back to Foyer. The doors open and a hand slips out with the token attached. Registry Client takes it, walks back to you, grabs your hand, and you transport back to CDN, and then back to terminal point. Your token is written in your npm-rc file. You are now logged in. Book 3, Chapter 1. Now that you are logged in, it's time to install. You look around and are surrounded by nothing. Terminal point is empty with the exception of you and the CLI. Your mouth starts making a sound like it had made 1,000 times before. npm init -- yes. You're not sure where that came from or where you'd heard it, if you've ever heard it. But there it was. And now in front of you is a package JSON file. You look at the CLI once again and say, npm install express. Shishigami arrives and looks around. Seeing no node modules folder and no package lock.json, Shishigami whistles and Pakoche arrives, carrying Kakash over her shoulder or in her hand like this. They speak quietly. They put together the address. Pakoche grabs your hand and you disappear again, back to the CDN. Book 3, Chapter 2. Once again, you walk up to the shopkeep. Pakoche speaks. Check my accept header. Ah, I see you're here for the corgi of an unscoped package. Excellent. Go along. You remember from before that a corgi is a metadata file for the package requested. It's significantly smaller than your standard JSON representation of the package, and it includes dist tags, version numbers, and each version's dependencies. Since the package is unscoped, it is a public package, so there's no security to worry about. All public packages are readable by everybody. CDN sends you to a specific address in the Cave of Wonders. You arrive at the Cave of Wonders, an S3 or Google Cloud Storage instance that is the home of packages and their information served right from the disk. Who disturbs my... Oh, hello, what do you need? We're here for the corgi of this unscoped package. Here is the address. Very well, go right along. You get your corgi. And take it back to CDN, who then caches it for quicker retrieval the next time it's needed. After that, you head back to terminal point. Once arriving, you and Pakoche hand over the corgi doc to Shishigami, who reads it and then sends the two of you back to the corgi for each dependency. This occurs until all the corgi docs are retrieved. Once Shishigami has all the docs necessary, it produces a dependency tree. You've gained a dependency tree. Now that you have your dependency tree, the tool begins glowing again. It calls upon Pakoche to get the packages. Pakoche sees the versions and packages needed and uses those to create new routes to request. This time, it's TGZ files, tarballs. Pakoche checks inside of her bag. It's empty. She pulls out Make Fetch Happen, says a few words, grabs your hand, and once again, you're on the road to CDN. Tarballs are CDN's specialty. Exciting. Pakoche walks up to CDN. It says here that I need to reach this address. Oh, let me see if this is in my cache. It is. Here you are. Thanks. And you're on your way back. CDN's caching system stores cacheable tarballs at its points across the globe. That means that public packages have been downloaded by other users, can be saved after they've been retrieved from the package servers. This makes for an extremely quick experience. Pacoche's make fetch again stores the package away for you in cache, just in case you need it again. Side note, if you use npm install -- prefer offline, you can just hit every time with no network hit cache first. And if you've installed it in any package, it automatically, that's where you end up downloading from. So you can do it with no network hit. So if you've installed for a project before and nobody's added any new stuff, and maybe the directory got wiped out, prefer offline will, like, you could do it on a plane, like even a United one. Their internet's terrible. Sorry if you work on United stuff. On to the next package, array flatten, version 1.1.1. And back to CDN you go. On the way, you ask Pacoche, do you really make one trip at a time? Pacoche laughs. Oh, dear developer, this is Node.js, and some guy's just on a stage teaching people about how this works. Of course, it's async. We're walking through this serially for learning benefits. You nod. It says here that I need to reach this address. Oh, this is certainly an unscoped package, so it's public, but it isn't in my cache. Let me send you along to the Cave of Wonders, to that specific file. You arrive at the cave. Who disturbs my soul? Oh, hello, JD. We're here for this specific unscoped package. Very well, go right along. You grab the package and head back to CDN, who asks if she can make a copy, in case someone else wants this later. Then you head back to terminal point. This continues through all of these public packages. Pacoche checks cache, does not have the necessary package, heads to CDN. She either has the package or not. If not, she sends you to the closest package server and makes sure to cache the package on your way back. Once each of the packages has been downloaded, Pacoche begins the extraction. The tarballs are untarred and placed into the node modules directory to match the tree. The tool glows again and begins to run its lifestyle script. Lifecycle script. Lifestyle script is a totally different thing. npm install fashion sense. You hear a song sing the words. Pre-install, build, install, post-install, finalize, refresh package JSON. Your package JSON has changed. All your files are properly placed and built, and they are now requireable from your project, and you can use them. The end? Book 4, Chapter 1. Oh, I'm coming up way over this time, sorry. All things are peaceful again. You can move quickly and build your web application now that you have a framework in place. But you need another package, and this time it's a private one for your org. You pull out your trusty CLI and speak into it. npm install my private package. Shishigami arises again and calls upon Pacoche for you to get the corgi for your scoped package. You and Pacoche head off to the CDN. CDN asks what you're here for and notices that your corgi doc request is for a scoped package. Before you can say anything else, she opens the door and sends you along to the next step on your quest. ID Authify, master of all things auth. I mean all. Both ones. Book 4, Chapter 2. ID Authify, the master of auth and protector of the cave, carries the keys to your journey to package server. She will make sure that you are who you say you are and that you are capable of viewing that package. Then she will tell CDN if you are worthy. She asks you for your credentials, mainly the authentication headers that CDN makes sure you have and sends you to the Eye of Authn. In the script that we'd run inside the CDN code will wipe out the headers that you try to send in case you're all hackery, and then replace with headers that are special and local. Anyway. The Eye's true name is Identify. Oh, did I mention? She asks you for credentials, mainly the authentication headers that CDN makes sure you have and sends you to the Eye of Authn. The Eye's true name is Identify. I tried to get it to be named Eye of Authn, and nobody was down with that at npm, which I find very unfair. That name is sick. and you come to it from IDAuthify. It wants the exact request you came with, and it examines your headers. In particular, it cares for your authorization, cookie, and CDN client IP headers. Since we were unable to bring a session cookie from which to feed the eye, it will have to look into our authorization header. An authorization header includes the scheme and the credentials being used. For the eye, the scheme is bearer, and the credentials are your authentication token bestowed upon you when you logged in. If your credentials match the records that Identify keeps, it gifts you with the sigil of your house. Sure, let's go with that. You will no longer be questioned, and you will be sent along your way. Now, how does it check? Remember logging in. When your token was created, it was stored in a Redis instance. Man, my voice is going, so now I'm just like back to speaking normally. It was stored in a Redis instance that is now being referenced by Identify. As long as that token remains in Redis, it is valid to reference and can be used to get through Identify. The tokens that you've used are available there. We will never deploy or display your entire tokens. Also, I have way too many tokens and probably should delete some of those. That is a security hazard. Now that your token has been retrieved, it is set as the value on the response back to IDAuthify, a bearer header. That header is your sigil. You have successfully been authenticated. Congratulations. Now that you have proven that you are who you say you are, you show your bearer header to IDAuthify, who then will find out if you are capable of accessing the package that you would like to install. In order to get this information, IDAuthify checks with the keeper of user authentication data, user auth cache. For the sake of things, let's just say that user auth cache goes and finds out via user ACL2 and payments API. And today is a good day for you. Nothing has been invalidated in the wrong way. You have your cache. The cache says, hey, this person is who they say they are, and they have access to what they want. The news is good. You are now allowed to proceed back to the CDN with your head held high. If user auth cache returns with bad news for IDAuthify, you receive the mark of forbidden, which is a 403. For Chapter 4, now that you have permission from IDAuthify, you return to CDN with new credentials. She checks her cache to see if there's an entry with these specific credentials and this package. It is not there. She opens the door to the path of the Cave of Wonders. You go get that fuzzy little doctor, the corgi doc. You turn around and head back to CDN. She caches the package in the way that only you can retrieve it. Back to terminal point. You got the hang of this. You have the metadata, you have the tool of your valor, and you know the path. So join Pacoche and follow the same route to get your packages. I really like Keynote. With your bravery, hero, you've once again opened the doors to the promised land of the NPM registry. Now the 10 million voices that call out for hope once again can appease their gods and their masters. That is, until they overthrow both. Thank you. Wait, what? Hero, it appears our quest is not quite done. Hero, we've been approached by the protector of the realm, Lift Security, and they have joined our party. With them, they have brought a tool, one to slay the evil spirits of security flaws in your application, the Node Security Project. The map must be redrawn.